In the last few years, our research has really been focused on a paradigm shift in the way that we predict the ground shaking that's caused by earthquakes. And we do this by explicitly incorporating all of the important physical phenomena that are associated with the earthquake rupture and the ground motions that radiate away from that earthquake rupture and travel throughout the Earth's crust. The main impact of this research really is by us being able to differentiate between areas that we know are consistently going to have strong earthquake shaking from other areas that we know are consistently going to have weaker earthquake shaking. And that really allows us to optimize the resilience of our built infrastructure, for us to spend more money in areas which we know are much more vulnerable to earthquake shaking, and areas where failure of that infrastructure is going to be critical. And then conversely, we can actually save money by reducing our investment in areas where earthquakes are less important, or pieces of infrastructure where actually their failure is not as catastrophic. So overall, it helps us to achieve that balance between the amount of money that we need to invest to actually achieve the resilience that as a society we're interested in. So our research has really been focused on understanding lessons from the Canterbury earthquakes, and then now more recent earthquakes such as those in Kaikoura in 2016, to really understand the impacts both for other locations in New Zealand, what that might mean for Wellington in future earthquakes, other major areas like Auckland, but also the lessons that we're learning because they're based on fundamentals. We can understand the implications for other countries around the world where earthquakes play a big role, such as in California, in Japan. And so our work has really been acknowledged as having that international importance through several accolades that we've received in the recent few years. The prize is an acknowledgement of the work that we're doing associated with earthquake science and earthquake engineering is really recognised at a national level as being as significant as any of the work that's done in the sciences. And I hope that in a country where earthquakes are particularly important, that is New Zealand, people take comfort from knowing that the work that's going on here really is at the cutting edge. More personally, I think this accolade is really important for many of the students and other researchers that I interact with on a daily basis in order to acknowledge to them the significance of the work that they're doing.